Section 4.3 is using SSS and SAS to prove triangles congruent. You'll know what that means in just a minute. So the SSS stands for side, side, side congruence postulate, which states that if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. Now, what I would like for you to do is come over to your triangles on the paper and give this an ABC, and give the other triangle a P, R, Q. And what the side, side, side postulate says is if three sides are congruent to three sides. Note that side AB is congruent to side PR, side BC is congruent to side RQ, and side AC is congruent to side PQ by the notch marks. And I would make a statement that triangle ABC is congruent to triangle PRQ. The order in which you make the statement is important. So if I start with A and I go along the single notch side to B, I have to also start with P and go along the single notched side to R. Then I'm going from B to C, so I'm going from R to Q. ABC is congruent to PRQ, and that is the only appropriate way to make the statement. You must state the angles according to how they correspond from triangle to triangle. So for example, number 1A, it says determine whether the following triangles are congruent due to the SSS congruence postulate, and if so, write a congruent statement. And since we see a single notch, a double notch, and the triple notch, and the same markings on the other triangle, then I would say yes, and I would make the statement that triangle ABC is congruent to triangle EDF. Remember, if I said A to B, and then I went from B up to C, so triple notch, single notch, then I have to go triple notch, single notch, so EDF would be the appropriate way to name the second triangle. Part B of example 1, you have a single notch and you have a double notch, but you also know, so if it's not marked, you know that the two triangles share a side. AD is congruent to itself by the reflexive property. So now we do have side, 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 and my statement for this one could be triangle ABD is congruent to triangle DCA. Okay, here we have included angle, and what an included angle is, it's an angle that is between two sides. So here we have a side, and here we have a side, and then the included angle would be the angle that's in between. This vocabulary is important because it becomes part of your next postulate. Okay, so for this guy, if this is called the side angle side postulate, we abbreviate SAS. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So basically what we would have is if two sides and the included angle are congruent, then the two triangles are congruent. And if I give some labels to my triangle, we'll call the first one on the left ABC, and we'll call the other one XYZ. Sorry. And my statement then would be that triangle ABC is congruent to triangle XYZ by the side angle side postulate. So for my example number 2, it says determine whether the following triangles are congruent due to SAS, side angle side, and if so, write the statement. And I can see that I have two sides in the included angle of one triangle congruent to two sides and the included angle of the other triangle, so I would say yes. And my statement would be that triangle ABC is congruent to triangle EDF. Part B. Now, if I look at what's marked, I see two sides congruent to two sides. And the angle wasn't marked, but we know we have a set of vertical angles that are congruent. So I do have side angle side. And this time I'm going to call my first triangle ABD. And I would say that is congruent to triangle EBC. Okay, and part C, let's see what we have here. We have two sides congruent to two sides. But the angle that was given to us is not in between the two sides. It's not an included angle. So for this one, I would say no. The angle is not an included angle. So even if I look at the triangles and they appear to be congruent, if I'm trying to prove congruency by one of the postulates, the conditions have to be fulfilled. And in this case, they look very congruent, but I don't have enough information to say yes, they are. Okay, and we're going to be using some of the properties that we learned in order to do some of our proofs. And so I just want you to go back and remind yourself what these properties say. The reflexive property says that anything is congruent to itself. So you might have side AB is congruent to side AB, or you might have angle A congruent to angle A. The symmetric property was when you had a statement that you could turn around. So if segment AB is congruent to segment, let's say PQ, then it's also true that segment PQ is congruent to AB. We're just reversing the order. And then for the transitive property, maybe if I use angles this time, if angle A is congruent to angle B, and angle B is congruent to angle C, then my conclusion would be that angle A must be also congruent to angle C. And those are the properties that we learned in the previous chapter. Okay, so now we're going to actually do a real proof. And in this case, there's some given, and then they're asking you to prove that the two triangles are congruent. So this is the way we do it. We take the givens one at a time. So I'm going to start with the fact that HF is congruent to HI. And I prefer the diagram is not already marked, but in this case it is marked. So I usually make the statement, I give the reason, it was given to us, and then I go to my diagram and I would actually put the notch marks on there. It was already done for us, but I'm just going to go through it the way I would do it from really the beginning. Okay, take your next given, which says segment FG is congruent to segment IK. So we're going to mark it. And that was also given to us. And then the third given is that H is a midpoint. So H is the midpoint of GK, and I'm doing a little bit of abbreviating here because I don't have quite enough room. That was also given. Now, what does it mean to be a midpoint? If H is the midpoint of the segment GK, then doesn't that mean that from G to H is congruent to the segment from H to K? That's what a midpoint does. It divides a segment into two equal segments. So my next statement comes from the previous one. If H is a midpoint of GK, then GH must be congruent to HK. And the reason I'm going to give is I know what midpoint means, so I call this definition of a midpoint. And now if I look at my two figures and how they've all been marked up, I know I have enough to say what it is that I'm trying to prove. I'm trying to prove triangle FGH is congruent to triangle IKH. And I can now say that because of the side postulate. I have three sides of one triangle congruent to three sides of another triangle. That is how we do formal proof. So for example number 4, this time they're not asking me to do a formal proof. They're just saying that take a look at your diagram. If you're told that RS is congruent to TK, what other information would I need to prove that the two triangles are congruent using side angle side? Well, by just observing the diagram, I know that the two triangles share a side. So side SK is congruent to itself. I know that by looking at it. So what's the missing information? The missing information is the angle that's in between, the included angle. So what I'm missing is the fact that angle RSK, so I'm going to say I would need to know that angle RSK is congruent to angle TKS. And if I knew that, then I could prove the two triangles are congruent by side, angle, side. And that is your 4-3 notes. We're going to do lots of practice with this in class.